everybody, today we'll do another video, and today I will continue with circuit analysis. We will touch on a subject that is called source transformation. Source transformation. So source transformation is a technique that helps us to analyze circuits, and as the name implies, right, source, right? So we have a voltage sources, so we have a current sources. So in this case, we said that the source transformation depends on what you have, right? So if you have a voltage source, for example, right here you have a voltage source. You go from negative to positive, right? And then you have something like this. So you have something like that. That becomes something like this. Those are equivalent. And then you have, let's say this is R, right? RS, I guess you can, R source. Then that becomes a current source, right? Like this, with a resistor in parallel, right? So that would be RS, right? So in other words, this one, let's say for example, this is whatever, 4 amps, right? And this is 12 volts or 10 volts, whatever, right? So you have a source transformation. You went from here to here, and you can go from here to here. So either way, this statement is valid. So, and also, of course, it's supposed to have like little thing right here. This is A. This is B. A. Right? A. And B. Which technically what I'm saying is that this is the source, right? And this voltage source is in parallel, it's in series with this resistor. And this current source is in parallel with this resistor, right? So that is the idea of source transformation. Now, what we can do, you can get my eraser. Okay, so what we can do, we can work an example. And also we can write a little formula here. So we know that voltage, just to help us out where we're going with this, right? So we know the voltage is equal to Vs, like voltage source, right? Is equal to Is times Rs, right? So actually the book has small line like that. Also, you can say that the volume over here solving this, right? For I, you can say that Is, or you can say the small Is is equal to Vs over Rs, right? So those are the two little formulas that we actually, basically, it's kind of Ohm's law, right? So now, based on this, we can just do a problem and see what we get, right? So, so the problem states, find, it says, find B naught in the following circuit. Right? Find B naught, right? So this is the how it looked like. So basically, it has a voltage source, right? Like this. And then let's see. So it has a voltage source. Actually, it has a voltage source on the other side. So actually we have, I don't have anything in that, well, yeah, I have a resistor right here. And then I got another, I got a current source, right? And that current source is going down like this, right? And that is 3 amp. 3 amp, right? Then I have another resistor right here. And that resistor is 2 ohms. And this is 4 ohms. Right? And then I got a resistor here. And this resistor has a plus and a minus like that. And this is 8 ohms. And this is B naught, right? But then the circuit continues to the other side of this. So, and then at the end of that, I have another resistor. And then I have a voltage source from, it goes plus and minus like that, right? So with that being said, right, then this is a 12 volt, right? So in this right here, the top is a 3 ohms, right? Okay, so we have a voltage source. This voltage source is attached to this leg of the resistor. And from this resistor to this resistor, I have a node here. And from this node, right there, I got another resistor going down, and it's connected to this node, right? So you can consider the whole thing as ground on the bottom here. Kind of help us out a little bit, right? So this is the whole thing is ground, right? So this is resist. This is a voltage source coming over here, coming in, and then going down, right? So and then from that, I have this A resistor, right? A resistor connected to here in this node, right? And then this leg of this resistor is connected to this whole ground node right here, right? So now from here, I got another resistor, another leg of that resistor coming in, right? And this connected, in this, it is kind of in parallel with this voltage source, right? Now, I got another resistor over here, right? And the whole thing is ground over here, right? So, okay, so now the question next, right? So how do I do the source transformation, right? So remember, if I have a parallel, I can go to series, and if I have a series, I go to parallel. That's how we deal with this, right? In this case, I have a resistor and a current source in parallel, right? So if I have a resistor and I have a current source in parallel, I can say the Vs, right? B source in this case, B source at 4 ohms, right? B source at 4 ohm, you can say that. I guess, like you can label this B source 4 ohms, right? B source of 4 ohm is equal to 3 times 4, right? Because it's Bs is equal to IR, right? IR. And R over here is I is 3 and 4 is, and R is 4, so therefore it's 12 volts, right? Now, I done this. But remember, this guy that I used to do that, it had to be in series now, right? It had to be in series because I am doing the voltage. So this resistor had to be in series with this voltage source. So the new circuit is going to look like this. So it's going to have, that's going to be a 4, right? This guy that I'm using, right? 4 ohms. And then I'm going to keep that 2 ohms, right? And because I already used this, then this becomes the parallel source, right? This current times that voltage, this resistance times this current is the voltage, so that disappears, right? It's transformed now, transformation, right? So that's basically, right here now I will have a voltage source of 12 volts, right? Now I will have something like this. So now that disappears and becomes this one, right? But at the same time, look at this side, right? At the same time, I have to do the same thing over here. So this is in series with this. So I got to do the opposite. I got to find I, right? Over here, I found volt. Why? Because there was some parallel. This is in series with this, right? So therefore, I do I. So I do I at 3 IS, right? 3 ohms is equal to what? It's equal to this divided by that, which is 12 over 3 is equal to 4 amps, right? So now this guy right here becomes a 4 amp, but then this resistor over here that was in series now becomes in parallel, right? So I hope this is clear, right? So this becomes in parallel. So now this is a 3 ohms, right? And then, actually, you know what? Let me just make this 8 ohms. Because this is technically, this is what I'm looking for, right? 8 ohms, right? And this is V out, right? So, but over here I will have 3, right? The 3 ohms that I use, right? This 3 ohms that I use over here, that becomes in parallel, right? So it becomes in parallel with this, right? And this now is going to be the current source of 4 amps, right? So 4 amps, right? And the current is going like that. Okay, now look what I have. You see, like I didn't do too much, right? I just made from one mess, I kind of create another mess, right? I got a voltage source, I got a current source, but now look at this. Those guys right there are now in series. And are now in series with this. You can see that, right? Now, if these are in series, I can make that in series, right? Like this was, and I can make another current source, right? So now, making a current source, and this becomes this, you can say that this is, make this like R1. I might have fact, to name it like R1, R2, right? And you can make it R3 or whatever, R3 and actually R3 and R4. This is just for label and stuff, right? Okay, now you can see that this guy right here, R1 and R1 and R2 right here, right? R1 and R2, those guys give me a series of R in series, right? R in series is equal to what? Is equal to R1 plus R2, and R series is equal to 6 ohms, right? So now you can see that those are done, right? Now, but the thing is, why I'm doing this? Well, I am doing this because I need to find the other current, right? So now I can say the R, I, right, is equal to what in this side? Which you see is equal to, you can say that this is I1 or whatever, right? I1 is equal to 12 over 6 ohms, right? Which in this case is 2 amps. All right. So now I can replace this, right, in parallel, right, with that source right there. So now let me just write this right here. So now I will have something like this. I will have a current source down like this, right? Coming down. Like this, right? And then I will have, right? And I will have this 6 ohms right here, right? And then I will have this 8 ohms, let me just make this up here because I need some room. So, right, so this is 2 amps, right? This is 6 ohms, right? 6 ohms, right? And then I keep going like this, and then I go like this, right? Now here we can actually see that, but this guy right here, right? So this is 8 ohms. I don't know. It's probably the camera is going to have a hard time seeing this. So let me just make it a little bigger like that. Right. So this is plus, this is minus, and this is V out. I need some room anyway. All right. So now, but then this is in parallel with this, right? Now you can actually see that this is 3 ohms, right? And also, I got another current source, right, like that. So, and this goes like this, right? Now, this is a 4 amps. Yeah, that's a 4 amp, right? Now you can see that now I have 3 resistors in parallel, right? 1, 2, and 3. And this guy is what I'm looking for, right? And also notice that I have 2 currents in parallel. When we have 2 currents in parallel, that means that we add them together, right? And I can say that now, you can say that S, you can actually name it whatever you want, right? IS, you can put it I source new, whatever, right? That is equal to, you can put this I1, right? You can name this I2, right? And you can say that I new is equal to I2 minus I1, right? Say that I2 minus I1. So what do you do here? So I source new is equal to what? Is equal to 4, right? This guy minus that guy is equal to 2, which is equal to 2 amps. Right, so now we got a 2 amp. Now I got rid of this and this, right? Now the new circuit is going to be looking like this. So now this circuit is going to look like this. So it's going to look like this. So you're going to have a source of 6 ohms. I'm sorry, a resistance of 6 ohms, right? And then it's going to be 8. So it's going to be 8 amps, right? So plus and minus, and it's going to be 8 ohms, right? So over here is 8 ohms, 6 ohms, 8 ohms, right? This two. Plus, actually, and then that 3 ohm resistor that is hanging right here, right? So that, and then we have that current going up like this, and that is 2 amps, right? So you can see that now I have 3 resistance and 1 source, 1 current source, right? Now I am looking for these guys. I am looking for the voltage. Actually, he actually put V out. Well, yeah, V out. Right? That's what I'm looking for. Okay, so think about this. So these guys are in parallel, right? So I can say that R parallel, right? R parallel is equal to R 6 ohms times R 3 ohms divided by R 6 ohms plus are 3 ohms, right? When I do that, I get that R parallel, right? These two, right here, these two, right? This and this is going to be equal to, is going to be equal to 6 times 3 over 6 plus 3, which is going to be 18 over 9, which is equal to 2 ohms. Right? So now that is the new resistance, right? So now I take this, so now I got rid of that, right? And I have only 2 resistors now, right? It's going to be this one plus that one. So now I can say that this resistor, this 8 ohm resistor, right? That 8 ohm resistor, right? And then this 8 ohm resistor, right? And that one, which is 2 ohms, 2 ohm resistor, right? Now that is in parallel. Now this is in parallel with what? With the same thing, which is 2 amps, right? 2 amps, right? So two amps, right? So now that is 2 amps, and that is right there, 2 amps, right? Okay, so, and remember, this is the guy that I'm looking for, right? B naught, right? Now, think about this, right? This is when the analysis comes in very handy to do circuits. You can see that this is in parallel, right? So this voltage right here, or amp, this current source is going in this direction, right? But this guy and this guy are in parallel. So the rule for resistance in parallel mean what? Mean that the voltage is the same, right? And the rule for series, okay, let me try to say it again. Maybe I say it wrong. We say that the voltage in resistors in parallel, the voltage across is the same. We say that the resistors in series, right? We have a voltage drop. So the voltage is different in series, resistors in series, but the current is the same, right? So in this case, even like the same voltage that we will have over here, it will be coming over here, right? So we can solve this problem in a different way. One, we can actually see the total sum of these guys in parallel, or we can do the current division, right? To find this first, and then whatever goes over, whatever voltage we get over here is going to be the same over here. Okay. Well, we can do that, right? So we can do I, right? We can do I. We can call it I. We can call it I 8 ohm, right? The resistance, the current within this guy, right? It's going to be 2 amps. So in other words, it's going to be, you can name this R, you can name this R1, and name this R2, right? So it's going to be R1, right? R2. So it's going to be is going to be, wherever I'm trying to find, this guy, this opposite is going to be on the top. So it's going to be R2 over R1 plus R2 times what? Times I source. Times I source. And what is I source in this time is 2 amps, right? So we say that I at 8 ohms, right, is equal to 2, right? This, the opposite of whatever I'm looking for, right? The opposite, which is this, right? This goes to the top, this goes to the bottom, right? The A goes on the bottom, right? So then it goes, and then we said, okay, so we said that is multiplying by 2 amps, right? And then, matter of fact, you don't have to put 2 amps, just, we're dealing with current already, yeah. Okay, so now we can say that it's going to be, it's going to be 8. So it's going to be 8 plus 2, right? So 8 plus 2 is 10, right? And this is 4, so it's going to be 4 over 10, which is going to be equal to 0.4 amps. 0.4 amp, right? Now we have a 0.4 amp, right? So now I am looking for this voltage, right? Now we can see that by Ohm's law, we can see that we have the resistance, right? We have the resistance with this 8 ohms, so we can say that V naught is equal to A ohms, right? A times I. A times I at 8 ohms, right? In this case, it's going to be equal to V naught is going to be equal to 8 times 0.4 times 0.4, which is equal to 1.6. So no, it's going to be 3.2. 3.2. So 3.2, right? And volts. It's the volt now, right? So now V naught is equal to 3.2 volts, right? Now, think about this. Now I can do the other way, right? I can prove it that it's the same thing. So now what I can do is say, okay, in this case, this guy and this guy are parallel, right? So I can say that V 8 ohms or V a parallel, right? We can say that V a parallel, V naught is going to be equal to, yeah. So V naught is equal to A in parallel with 2, right? With 2 ohms, right? And then if we do that, right? And we multiply that by the 2 amps. Yes, by 2 amps. So by 2 amps. So we do that by 2 amps. Okay, so how do I do a parallel with this? So I do V naught. Actually, let me just do it right here. So R parallel total is going to be, R parallel total is going to be this two, which is going to be R1 plus R1 times R2 over R1 plus R2. right? So now this is going to be RT is going to be equal to 8 times 8 times 2, right? 8 times 2 times 8 times 2, right? Which is going to be, and then 8 plus 2 is going to be 16 over 10, which is equal to 1.6 ohms, right? So 1.6. So now 1.6, right? So now V is going to be multiply this guy, right? So this times 2. And so V out is going to be equal to 1.6, right? 1.6 times 2 is equal to 3.2 again. Right? So 3.2 volts. You can see that that's the same thing, right? So we found now that the voltage across this resistor, right, between ground, right, in this node right here, the voltage across that resistor is simply 2.3 volts, right? And you can see right here that it's going to be the voltage across over here is going to be the same, right? Right? So yeah. So so that's how we solve the problem, right? Using the source transformation, we take the source, we take the whatever sources we have, and then we just transform them back and forth until we get at the end. In this case, we had 2 current. We were able to eliminate, right? These 2 current, eliminate to make it one source, right? And then reduce it as much as we can by using the series and parallel circuit type of technique. And then we made it a parallel circuit with the 2 amps, right? And then we found out that the voltage going across this 8 ohm resistor is 3.2 volts, and also we prove it by finding the total resistance in the circuit, because this is in parallel with this. The whole thing is in parallel with this. We found out that the total resistance we found over here, right? And doing all math, and we found out this is the same thing. It's 3.2 volts. Right, so thank you for watching, and I see you in the next video. Remember that we learn something every day over here because Jesus is good with us. Thank you for watching.